Today's 22nd of September 2025, about stochastic process. I'm going to expand the things from news vendor model. News vendor model, that there are very simplified assumption. We will later talk about how to extend it, and we will talk about this. In news vendor model, we can find the threshold, then we can find policy. What is the policy? Policy is the thing that uh, we can find we can find something in a whole level. I will say we can find things at the we can find things at the mm, one or contingent value x. Here amount is x, and two readily variable solution. If you have policy or strategy, right? That's what is nice, which means everything is you pre-computed, then you can have less time to make decision making. We don't know it is good or bad, but anyway, we can, we don't need to do other decision making. That would be the very good thing. And now what I'm going to do is mm, gonna stop the, yeah, now I'm gonna write it like a little bit. For decision making, like this. So in your standard model, if you think of it, there was one, two, one, three, yeah, one, four, one, five, and there was demand and there's preparation. So this would be optimal preparation. And if you go down here, and if you go up, there is prepare, more, prepare, cost of, we're calculating cost of over preparation, and we're calculating cost of under preparation. So um, the amount, the F1, which is how much we should prepare. This F5 is also failure rate, how much we prepare. Failure rate is calculated by the, mm, how does it calculate it? It's calculated by CU, CO plus CU. And we can also compare the department store and outlet. Usually department store, even you go at the almost at the end of the time, they can sell the product. Why? Because they have high cost of CU, which is cost of underprepared. So they always uh, higher CU makes uh, which you should means we should well prepare. So they probably they well prepared about things. We usually see you in the simplest model. We can calculate CU very simply, which is when you're not prepared. When you're not prepared, you will lose chance to make profit, P minus E. And when you over prepare, you will lose the uh, what you lose is you made a chance to make profit, chance to make profit, and in this case, cybersecurity. When you prepare it, you will lose this kind of thing. There will be also uh, expectation of profit will be calculated by uh, price multiplied by how much we can sell, which is minimum of demand, and we prepared. And there will be salvage value, which is E x and this difference and each loss Yeah, so basically, the two things are same. Minimum of, wait a minute, I think I need to confusion and which is also minus cost. I'm confusing much. Want to check it. Then how we calculate is if we this is basically we should write down the CDF. Then it would be like if it is a uniform distribution going to 40, then we can calculate write down the CDF like this. Then based on this value, we will get this value. Then what we should find is this x point. So y equals to something. We will get y equals to something. Mm. And if new spectrum model gets complex, what happens is there can be disposal cost or holding cost additionally add over the situation. We can intermediately calculate disposal and holding cost. Also, we should think about reputation loss and compensation to customer if it gets complicated. So in solvent management case, there's such example like next month's production and manufacturing company will use a certain solvent for part of its production process. You need to prepare solvent in prior, and the demand of solvent is random. Assume that there is an ordering cost of $1,500 incurred whenever an order of solvent is placed, and the solvent costs $50 per liter. Due to the short product life cycle, a new solvent cannot be used in following months. There will be a $15 disposal for this liter of solvent left over at the end of the month. If there is a shortage of solvent, the production process is seriously disrupted at a cost $100 per liter. Should assume the initial inventory level is X. Well, X equals to 0, 500, 700, and 800. Then what you should do is think about CU and CO in this case. Now I will open the note again. Wait a second, please. So what we are doing is in X equals to each case, how much we have, we will calculate whether we should buy or sell. If there's nothing, then we should just calculate it based on the only the PDF and CDF, but we have additional calculations. So what we need to do is we should now compare it. Let's see here, wait a minute. I need to check whether E min E X and E X minus D plus how does it different? For this one, in basic new standard model, this one is multiplied by price, and later part is multiplied by salvage cost. And you can like get optimal X prime. Later, what I mentioned to you, if you are going to calculate C, cost of underprepared, cost of underprepared will be 100 minus 50, which is 100. In this case, 100 is the production process is seriously disrupted at a cost of $100 per liter shoot. And also $50 is in case uh, solvent cost $50 per liter. Cost of overproduction case, it is 50 minus 15, minus 15, which is disposer charge for each liter of solvent left over. Yeah, this is surface variation minus this. So if we are going to find optimal point, what we should do is we should compare it. What what would you do when x equals to 0? When we have none, then we should calculate the total cost when it is if order 560 at x equals to 0. Then we should calculate the value. We are assuming certain distribution, which is du equals to 300, comma 900. Then we will also think about the CDF in this case. And the value we need to find, it will be the, wait a minute, and we should compare this with when total cost, when total cost x equals to, if order is 0. And another, when x equals to 500, shall we buy or not? Then what we should compare is when x equals to 500, should he order none or should he order 60 to make 560? We should compare it. Then, and also when x is equal to 700 and 800, then later we can make a graph and we can find the threshold. If we want to solve it in optimal policy level, what we should do is just finding the value of x, which is total cost of, if ordering 50, s minus s at x equals to s is whether same with total cost if order 0 at x equals to s. Next time I will come back with handwriting. Thank you very much.